We're going to take a quick investigation into graphing lines. So we really have to understand what it means to be a line in the first place. And what that comes from is just lines are just relationships between two variables. So let's just make up a quick one here. So like if I have the equation x plus y equals 2. All this is just a rule that relates together these two variables, x and y. It's just saying that whatever x is, y has to be a number such that when I add them together, they equal 2 or they sum to 2. Or the reverse of that would be that if I pick a number for y, x just has to be whatever number so that when I add it to y, I get to 2 as well. So let's look at a quick table here of what this would look like. So if I pick values for x, let's just go with -2, -1, 0, 1, and 2. Well, if x is -2, what does y have to be? Y has to be 4. And if x is -1, what does y have to be? It has to be 3. If x is 0, y has to be 2. If x is 1, y has to be 1. And if x is 2, y has to be 0. So this is just a relationship between these two variables. That's all it is. There's nothing special about it. And so when we go to graph it, we actually don't need to change the form at all. We can just go and graph it. So if I give myself a quick pair of axes here. So what does this mean? Well, I'm just going to take each of these points. So -2, 4. So -2, 4, about there. And then -1, 3, maybe about there. And 0, 2, about here. And 1, 1, and 2, 0. So all I've done is graph these points, and what you can see is I have the formations of a line here. And all a line is just infinitely many points that satisfy this rule. So obviously there's non-integer points on here. There's negative values, there's positive values. There's infinitely many points that satisfy this equation. All it is just pairs of points that all line up and satisfy this equation. So there's nothing special to it. I know that a lot of times when we graph lines, what we want to do is, of course, just put it into slope-intercept form. We can do that real quick. So y equals the opposite of x plus 2. And what we can tell from this, what we know, is that this right here is the slope, which in this case is -1. And this right here is the y-intercept, which in this case is 2. Y-intercept. And so this is just the only reason I would change into this form is so that I can easily tell this information. There's nothing special about it. It tells me all the same information. It's just it's more readily available that I can see what the slope and y-intercept are. And so there's actually multiple different forms that I can put a line in. And so let's take a look at those real quick. So there's different forms. The three common forms that we're going to talk about would be, well, what we just said, slope-intercept form. There's also standard form. And what I think is the most underrated, which would be point slope form. So let's just give us an equation that we can work with here. So let's say we have a line where the slope is, the slope is 3, and then a point that's on that line is the point -1, 2. So slope-intercept form, if I want to go ahead and make that line here, I can do that. What I know is that it's going to be of the form like this, y equals mx plus b, and I know what the slope is. It's 3. So y equals 3x plus b. Now I don't know what b is here, but that's okay. I can solve for it because I know two values for x and y that satisfy this equation. They're the points -1 and 2. So if I plug those in, what I can do is solve for what b is. So this will be that b equals 5, and so I can finish this out. My equation here is y equals 3x plus 5. So this is one form of the line that I have. And just by looking at it, I can tell what the slope is, it's 3, and what the y-intercept is, it's 5. Another one, so let's go look at point slope form. Let's do the same thing. So I think point slope form is actually a little bit easier here. So point slope form, it looks like this. So y minus y1 equals m, the slope, times x minus x1, where x1 comma y1 is just a point that's on my line. And so it makes it really easy, since I'm given the point and the slope here, I can just plug those in. And I can see that y minus 2 will be equal to 3 times x minus negative 1, so x plus 1. And so this is also an equation that describes my line here, describes the relationship between x and y. And so if I really want to justify that, I can manipulate this to go and look like the other one. And so I'll do that as well. Y minus 2 equals 3x plus 3. And then I can add the 2 over and get that y equals 3x plus 5. So these are exactly the same thing. They're just in different forms. Nothing has changed. I haven't changed the line. I've just changed what it looks like. So the last one here is standard form. Standard form, for being totally honest, is probably the most useless of them. I don't see anything right away from standard form. There are some things I can get out of it, but just not directly. And so I can very easily manipulate one of these to look like this. So if I just subtract over my 3x, I'll have negative 3x plus y equals 5. And I usually like to have my coefficient on x be positive, so I'll just divide by negative 1. I'll get that 3x minus y equals negative 5. So what I've done here is I have created 3 different representations of the same line. All these are the exact same line. If I were to graph any of these, I get the exact same thing. They describe the exact same set of points. They're just in different forms. Now I put them in different forms because I can tell information directly from them. Slope-intercept tells me my slope and my y-intercept. Point slope tells me a point and then also my slope. And the standard form is just a nice way of writing it. We'll use standard form a lot, in later classes, like if we wanted to graph something that's quadratic or just a greater degree than that even. So these are just different forms for the exact same line. So the next thing that we want to talk about then is the relationship between some lines, specifically lines that are either parallel and perpendicular. So let's talk about what exactly it means to be parallel in the first place. So I'm just going to go ahead and draw a couple lines here. I'm not going to give them equations. I don't really care what they are. I'm not going to find the slope or anything or find points on them. But if I have a line like this, what does it mean to have another line that's parallel to it? Well, another line that's parallel to it just means that it will never intersect. And so I can draw another line over here that never intersects this other line. And so they will go on infinitely in both directions, never running into each other. And the only way that that's possible is if they have this different offsets here, so different intercepts, but they have the same slope. They're going off in the same direction. They're increasing at the same rate. And so two parallel lines must have the same slope. So parallel lines must have the same slope. And so it's as easy as that to identify them. If I know their equations and I can see if their slopes are the same, I know that they have to be parallel. The slightly more challenging one is, well, what does it mean for a line to be perpendicular? So perpendicular just means that it's a right angle that's formed here. So let's see if I can roughly sketch that. So two lines are perpendicular if they intersect and form a right angle here. So we'll notice a couple of things about these. The first one is that if a line has a positive slope, then the line that's perpendicular to it will have a negative slope. It has to be decreasing instead of increasing. And then the opposite is true. If I have a line that is a negative slope, the line that's perpendicular to it must have a positive slope. The other interesting and a little bit tougher to notice is that my original line, the amount that it goes over and then up by, is actually, you can find it here in my perpendicular line. It will be the amount that it goes down and over by. So these two values here are the same, and then these two values here are the same as well. So it'll actually be the case that perpendicular lines, which are lines that have that intersect to form a right angle, will have what we called opposite reciprocal. Oh, I hope that's spelled right. Opposite reciprocal slopes. So what does that mean? Well, let's say I have the slope of, let's say, 1/3. The opposite reciprocal of this would be, so the reciprocal, I'm going to switch my numerator and my denominator, so 3/1, and then I will take the opposite of it, the opposite reciprocal, so it's just -3. Or if I have something that's like 3/2, for example, the opposite reciprocal slope would be -2/3. And so it's really easy for me to identify two lines that are perpendicular to each other because they will have opposite reciprocal slopes. So let's look at a quick example of this then. So let's say I have a line, let's make up another one. Let's say I have a line, we'll put it in standard form because why not? 4x plus 2y equals 3. Let's try and find the parallel line and the perpendicular line to this one here that goes through the point 1, 3. Okay, so let's start with the parallel line. The parallel line is easy. What I'm going to do is I need to find the slope that I'm going to use for my new parallel line. And all I need to do to find it is that it's going to have the exact same slope as my original line. So what is the slope of this one? Well, maybe let's put it into a form that would be easiest for me to find the slope. And so I'll put this into slope-intercept form. So this will be 2y equals -4x. Plus 3, and then I'll divide by 2, so y is equal to -2x plus 3, or 3/2, sorry. So now I know the slope. My parallel line has to have the same slope. So what I'm essentially doing is trying to find the equation of a line that has a slope of -2 and goes through the point 1, 3. So I can do this a couple different ways. I'm going to use my favorite form of a line, and that's using a point slope form here. So I can say that my new line will be y minus 3 equals, and then -2 times x minus 1. So this, I can stop here. If I'm just asking you to find the equation of a line, here's the equation of a line. If I really want to put this in slope-intercept form, I can do that as well. And so I can have y minus 3 equals -2x plus 2, and I'll add the 3 and get that y is equal to -2x plus 5. And that's it. That's all there is to it. I've now found the equation of a line that is parallel to my original one and goes through this point. And we can just as easily do this with a perpendicular line. So I'm going to start off by finding the slope. So if my original slope was -2, the opposite reciprocal of that, so the reciprocal of 2 is 1/2. And then the opposite, it was negative, so now it's going to be positive, and it still needs to go through the point 1, 3. Now I'm going to do the exact same thing here, where I use my point slope form, y minus 3 equals 1/2 this time, times x minus 1. And if I really feel the need to put this in slope-intercept form, I can do that. That's going to be y minus 3 equals 1/2 x minus 1/2. And then y equals 1/2 x. So if I add 3, I'll be down to 5/2, I guess. Yeah. And so this is the equation now of my line that goes through the point 1, 3 and is perpendicular to my original line. So it forms a right angle with it. So that's all there really is. For the basics of graphing lines, I have several different forms to put them in, and I can also easily find equations for lines if I'm trying to find them that are parallel or perpendicular to my original.